let's do this. So we started going over problems like this, but this is like what we're going to go over instead of the rest of section 1. All the rest of the packet is the same. It's just this is broken down a little different because I break it down by like rational functions, polynomial functions, and radical functions, and the piecewise a little better because this is what people will struggle with. So here we go. We already went over part of this, but a little review. Polynomial functions. The domain of any polynomial function is all real numbers. Polynomials are nice and smooth. Like, it's just this whatever line and it goes on forever. There's no holes. There's no asymptotes. There's no like jumps with random piecewise functions. It's just smooth. You can plug in any x value, any real number into a polynomial. It'll spit out and give you a y value. That's why the domain is all real numbers. So, example 4, state the domain of each function. Chelsea, how about A? What is the domain? So this is a polynomial. This is a polynomial. Polynomials have a base of x and different values of exponent. So the domain is all real numbers. That's one way to write it, but I want you to practice and write it in interval notation. So negative infinity to infinity. So although this is a linear function, it is a type of polynomial. X to the 7. So it's all real numbers because think of a number where if you plug it in, it won't give you a y value. There's no number that if you plug it in won't give you a y value. Any real number. Okay, so what about this one? This is also a polynomial. The domain is negative infinity to infinity. So we haven't talked about range yet. That will be later in the chapter. But domain, we're talking about the x values first. So domain is all real numbers. That means all the x have a y value. Right? You plug in any x value, it will give you a y value back. So the times when you won't have a y value is if you are undefined. If something's undefined. So whenever you divide by 0, right, it's undefined. That is when you wouldn't have a y value. So whatever x values would make it undefined would be when you exclude them. There's no way, nothing. No x value, if you plug it into b, it would make it undefined. Okay, let's go on to the next part. So, rational functions. Rational functions are literally ratios. Two polynomials on top of each other. It's a fraction. It's a ratio, a fraction. Two polynomials on top of each other. So, the domain of a rational function is every number except where the denominator will be 0, meaning the zeros of the denominator. Zeros, right? Wherever the bottom of my fraction's equal to 0, that's when it'll be undefined. Because literally, ready? 2 divided by 0 is undefined. So I have to look at which x values would make the bottom equal to 0. So think about how you would solve this. How do I find where the zeros, like where this function equals 0? Factor. Exactly. So, let's see, x plus 4 times x minus 3 is equal to the quadratic above, and then you set each factor equal to 0. So those are the two x values that if I would plug them into my function, it would give me 2 divided by 0. These are the only two x values where if I plug it in, it wouldn't give me a y value. It would be undefined. So what I have to do is I have to cut them out. I want to say any number except those two. So one way you could do this is you could say all real numbers, but x cannot equal -4 and 3. So that's all, nice and dandy, but we want it in interval notation. What if I don't want to know, what if I want to know, all the values where I can have it. Now that's not a very good way. How do I write this in interval notation? That's a better question. How would I write this in interval notation? Ariella. So I don't want it in set notation. I want it in interval. So lots of unions. Got three intervals that are getting married, right? Being joined together. Unions. They're being joined together. So a way I can think about this, here's my number line. Here's -4. Here's 3. And I want any number that will work. I want the domain, right? So which x values would have y values for this function? Well, I know for sure I can't plug in -4 because that would be undefined. If I plug in 3, it would be undefined. What about any number in between 4 and 3? Would those work? Mm-hmm. Yeah. Okay, so I'm going to connect them with a line, so I have to include those. Any number bigger than 3 would also work, and any number less than 4 would also work. So literally, it's going to be all real numbers except the 2 I cut out. Have you guys ever seen a VHS tape or a cassette tape? So the way they used to have to edit movies is they would have these like long spools of film, and they would literally cut the parts of the scene they wanted, and they would literally paste all of these little like chopped sections of film together. So that's like what I'm trying to do. So this portion right here, the negative infinity to -4, takes into account all of those numbers. Between -4 and 3 takes account of that. And then I have 3 to infinity. So I have 3 different intervals where there's a bunch of numbers that would work. Literally, the only place that doesn't work are the 2 places that make it undefined. And that's where my unions are, because I can't include those 2 numbers. Okay. Beat it into your brain, maybe. I don't know. We'll try another one. So let's try B. So h of t equals 3t squared over t squared minus 1. So notice we don't really care about the top. All I'm asking is for a domain, and the domain depends on the bottom. Because if the bottom equals 0, it will be undefined, and we have to cut those x values out. So I'm looking for where t squared minus 1 is equal to 0. Can I factor t squared minus 1? It is a blank of blank.
Difference of squares.
Difference of squares. Fastest. Buzzer beater. Difference of squares. How do I factor difference of squares? T plus 1, t minus 1. Okay, is that equal to 0? And the 2 places where the bottom of my fraction will be 0 are 1 and 0. I was just kidding, 1 and -1. So I have to include all numbers except those 2. How would I do it?
You -1, 1, and then you 1.
Exactly. And if you get this ironed down today for low price of an A+ in my class, you too can be successful in calculus. They struggle with this still, which is why I'm harping it into you. Where are the unions? Oh, the unions are literally occurring where it's undefined. That's where my union is occurring. Like, oh, at 1, x can equal 1. So I have a union, and then I have like the 1 on either side with parentheses because I'm not including 1. That's why it's parentheses and not square brackets. Cool. Try out C. Try out C. Did you have enough time to write? Are we okay? All right. So once again, interesting. We don't care about the top yet. The top will depend on, we'll talk about the top and like what it does later. But right now we're only talking about domain. And then slowly we'll sprinkle in more information like vertical asymptotes and horizontal asymptotes and the range. And right now, only domain. So we don't care about what the top is, whatever. The only thing we look at is what x values will make the bottom equal to 0. Once again, it's the same difference of squares. I probably should change that. So x minus 1, x plus 1. Once again, it's going to be -infinity to -1. Union negative 1, because I'm excluding negative 1, but negative 1.00001 is in my domain. It's just the 1 point of negative 1. That's the only one I exclude. And D. So try out D. So once again, we're just looking at the bottom. And I set the bottom equal to 0. So x squared plus 1 cannot equal 0, because if it does, shoop-de-doo, we got this undefined nonsense. What? Exactly. So it is. So I have x squared cannot equal negative 1. So x cannot equal plus or minus square root negative 1. Wait, all that means is x cannot be I or negative I. It can't be an imaginary number. But we here care about real numbers. So what number can I plug in that would make it like 0 on the bottom?
Nothing.
Nothing. If I plug in 0, I have 1 on the bottom. What about like negative 1? Negative 1 plus 1 is 0, but it's squared. Negative 1 squared is 1, and then, doesn't matter what value you plug in, it will always give me a number on the bottom. I can't make the bottom equal to 0 unless I plug in something that's not real, imaginary. So this would be a case where we have all real numbers. So you'd say negative infinity to infinity. What?
So, wait. So if it's a polynomial, or you can't find anything, it's a real number.
So it's
Is it ever?
so if you graph x squared plus 1, if you graph x squared plus 1, it looks like this. Like there's no solution because there's no place where it touches the x-axis. There's no place where it equals 0. So whatever x value I plug in, it will always give me a positive like y value up here. Well, I mean, I'm just looking for where it's undefined. I'm just looking for where this bottom equation would be undefined.
So if it's undefined, then it's all real numbers.
No. So if I have the bottom of my fraction equal to 0, that would mean whatever value of x would make the bottom go to 0 would make my whole function undefined. So that's where I would cut it out of my domain. Okay, x squared plus 1 is this graph right here. So if you pick one of these y values, so guess what? In x equals 1, my y value is 2. So instead of saying x squared plus 1, I would put in 2. Oh, wait, I'm not dividing by 0. So I'm showing the possible values I could plug into my bottom by this graph right over here.
No, I know, but we were trying to find the domain, and it said that it was a thing.
Yeah, well, the things that I would,
0.
the value to plug in that would make my bottom equal to 0 is imaginary. We're looking for real numbers to plug in that would make it 0. So since there's no real number to plug in that would make the bottom of my fraction go to 0, it's going to be all real numbers. Yeah. Okay. Perfecto. Okay, so that we talked about polynomials, we talked about rational numbers. So now, yeah, you're good. So now we're going to talk about radical functions. So this is why I've been being very specific about even roots, because even roots are different than odd roots. What the heck do I even mean by an even root? So an even nth root. So right now oh my god, come on, work. Oh, there we go. See ya. I'll have the screencast up. So if you just see a root symbol, that is the second root, and that's an even root. If I have a fourth root, or a sixth root, or an eighth root, those are all even roots. And if you think about it, what is a negative times a negative? Positive. So wait, if I try to take a square root of a negative number, that's imaginary, because no negative number times itself is going to be negative. The graph of a square root looks something like this, right? It literally starts at 0. Notice it's not defined for this left part of the graph. Same way, it roughly looks the same for the fourth root, sixth root, eighth root. They all look like that. So the domain for a radical function with an even root is the numbers for which the radicand is greater than or equal to 0. So you take whatever inside here and set it greater than or equal to 0. Now, this is in great contrast to an odd root. So if I have the third root, or the fifth root, or the seventh root, etc., you know the difference between even and odd. Do we know what the graph of this guy looks like? Well, we know it, like, what's the cube root of 27? What times itself? 3, right? So, okay, so positive is fine. What about, can you put a negative under a cube root? What's the cube root of negative 8? What times itself 3 times is negative 8?
2.
Negative 2, right? Negative 2. So a cube root looks something like this. It's defined for all real numbers. The domain of a radical function with an odd root is all real numbers, because it's defined everywhere. You could put in any real number under the root and it would give you some number back. Versus, you can't put any negative numbers under a square or even root. So only if it is a odd root do you say all real numbers. Only if it's an even root do you do the greater than or equal to 0. All right, state the domain of each function. So this is an even root because this is a second root, so it's even. So I take whatever's inside my square root and I set it greater than or equal to 0, and I just solve for x. And then we practice interval notation from an inequality. So if x is greater than or equal to 10, that means my domain in interval notation will be square bracket 10, comma, infinity. Yeah, how's that? Yeah. Okay, I want you to try B. This is mean. I don't know. This is kind of mean of me. So, you take what's... Oh no, did you guys need to be separated? Just keep looking back, making eye contact. Sketchy. Super sketch. Okay, you take whatever is inside the root, since this is a square root, set it greater than or equal to 0. I have to factor it out, because I need to solve for what x would actually be. Let's see, x minus 5, x plus 3. So I see the two places where x is the two zeros, the two solutions, zeros, solution, roots, those are all mean the same thing. The zero of a function, the root of a function, the solution of a function, zero, solution, root, means all the same thing. So I see my function would equal 0 if x equals 5, and if x equals negative 3. So I see there's some interesting things happening. So the issue is, those are the zeros of my quadratic. Roughly, right, what would this quadratic look like? Would it be facing up or facing down? So how do we know? Look at the coefficient in front of x squared, positive or negative? And if you're positive, right, you're probably smiling. Haha, smiling. The positive means the parabola looks up. If it's a negative coefficient, if you're negative, you frown a lot. A negative coefficient, a negative number in front of x squared means down, parabola is going down. Okay, so since it's a positive parabola, we know where our zeros of the function are. Negative 3 and 5, right? That's where it's going to be crossing the x-axis. Negative 3 and 5. So the parabola looks something like this, roughly. I'm sorry, it's not the best. Okay, so let's see. Let's talk about the y value. So if I plug in an x value between -3 and 5, it spits out a positive or negative number. What do you think? If I plug in a number between -3 and 5, does it give me a positive or negative number? It's negative because it's below the x-axis. If I plug in a number above 5, it's positive. If I plug in a number below 3, it's positive. So wait, what this tells me is, if I plug in a number, right, where I'm shading between -3 and 5, this whole thing right here is going to be negative. If I plug in like 1, ready? 1 squared minus 2 times 1 minus 15. It's going to be -16. Oh, then I'll be taking square root of -16. That's not good. So, who said what? You said what? Okay. So instead of saying x squared minus 2x minus 15, I'm just going to plug in an x value. What about if I plug in 0 for x? Would it be positive or negative under the radical? Well, plug in 0 into the equation. What do you get? Negative. Any value, any x value between -3 and 5, if you plug it in, will give you a negative number. And then you'll be taking the root of a negative number. So I only want to include the numbers that are greater than 5 or less than -3, because that would give me a positive number, and whenever I plug in that x value, it would make this whole thing under the radical positive. Okay, this is like some high level trying to have you understand like functions, and it's going to be really weird for you because normally in math you're like, okay, here's an example, ready, plug, chug, same thing on homework. Like, no, once you understand, right, from a high level, okay, I'm looking at what's under the radical. It's this whole quadratic, right? So if I'm looking at the y values of my quadratic, I only want the positive y values, because that would mean I'd plug in an x value that would make it to be positive under the radical. This is also a point where like they struggled last year, so I'm trying to explain it a little better. If I plug in 6, what do I get? If I plug in x equals 6, what do I get? -36 minus 12 minus 15, so that's minus 27. Okay, so I'll be 9. It's positive. So anytime I plug in an x value that's greater than -5 into here, I'll get positive under the radical. If I plug in an x value that's smaller, less than -3, it will give me a positive number under the radical. The problem is, if I plug in a number between -3 and 5, it will give me a negative under the radical. So I want all the numbers except for the ones between -3 and 5. So I want all the numbers except the ones between -3 and 5. So I'm going to say negative infinity. Do I want to include 3? Is it a solution?
Yes.
Yes, because it's greater than or equal to 0. -3 is where under my radical will be equal to 0. Union, square bracket, 5 to infinity.
Oh.
That's it.
You don't need to include the second portion.
I don't want to include this portion because that would mean putting a negative under my radical. Because imagine, you plug in 0 for x, what do you have? If you plug in x equals 0, what's your y? Look at the equation. Look at the equation. Plug in 0 for x, what's your y? -15. I don't want a negative under my radical. So literally, any of these points, any of these x values will give me a negative under a radical. So I just want to exclude this portion. Okay, I think I beat it into your brains. It's been a long day, I know. Don't worry. All right, so come on. All right, part C. F of x equals cube root of x minus 4. So what do I do here? Ariella? All real numbers. Why? Yeah, it's an odd root. Do you know what this -4 does? I mean, it just moves it horizontally. So it moves it horizontally. That's all. If it's inside the root, inside the absolute value, inside the parentheses, it's a horizontal shift. Don't worry, that's section 5 when we talk about parent functions and very quickly go through all the transformations. Just trying to prep you. No, I'm just showing you why it's all real numbers. Because it's always defined.
Is there a reason that cube root looks like tangent but rotated?
Yeah, there is a reason. Do I want to go through it right now, though? But I don't want to stifle your intellectual curiosity. Yeah, there's a reason. Okay. If we finish, the rest of the lesson I'll explain at the end. Otherwise, I'll just try to find a nice article and send it to you. No, it's a great question. I like that you recognize that. All right, let's try this one. If it loads, f of x equals 1 over square root of x plus 2. Wait, did we do this one already? It's kind of similar to what we did last time, but it's okay. All right, so 2 things going on here. It is a rational function because it's a ratio of 2 quadratics or polynomials, and we have a square root on the bottom. So first off, I know that this square root is going to be really, really restricted, right? Because x plus 2 has to be greater than or equal to 0. So that means x has to be greater than or equal to -2. But wait, the bottom of my fraction, I don't want it to equal 0, right? I don't want the bottom to equal 0. So I don't want it to be greater than or equal to 0. I just want it to be greater than 0 on bottom. Does that make sense? Well, I'm excluding the equal to, because if the bottom equals 0, it's going to be undefined. So then it's just going to be x is greater than -2. So I just have -2 with a parenthesis to infinity. Yeah. Bomby.com, yeah? No?
What?
Bomby.com? No?
What?
What? Huh?
What's bomb.com?
Bomb.com? You're the bomb.com.
Oh, yeah.
Bomby.com. Wow. I even went to sleep early last night. I don't know. Okay. Let's try the next one. Okay. So, this is a good one. Tricky trick. So, Ariella.
It's all real numbers because it's square root of 1. What? I'm thinking. Probably wrong, but
Because
it's
it can't
okay.
equal 6.
So, okay. Okay, so first things first. I can't have the bottom equal to 0. So x cannot equal 6. Right? So if x equals 6, the bottom goes to 0. Second thing, I can't take square root of a negative number. So up here, I know that x minus 3 must be greater than or equal to 0. So that means,
Yeah.
what?
Why are you
Because it has a radical. We only look at the bottom. So if it's a pure rational function where the top is a polynomial, we just ignore it because that's all real numbers. The top, if it's just a polynomial, it doesn't affect the domain restriction. But the top here is a radical, right? Root x minus 3. I can't have a negative under the root. This is literally the only time we're gonna look at the top. These roots. So I know x has to be greater than or equal to 3. So if I would draw a number line, so I know at 6, it can't equal 6. And I know x has to be greater than 3. Greater than or equal to 3, and it can't equal 6. So it's all the numbers greater than 3, except it also cannot equal 6. So to write that, I say 3 to 6 union 6 to infinity. Notice the square bracket by my 3 and the parentheses by my 6. Yay. Yeah. If you're done, try the next one. F. No? What's wrong? So I knew that I only can plug in numbers greater than 3, otherwise I'll be putting a negative under here, right? So I'm like, cool, all numbers greater than 3, except, wait, if I plug in a 6, the bottom goes to 0. So that's why it's all the numbers greater than 3, except I can't plug this 1 in. It's fine, like, you guys are doing fine. This is hard. That's why we have practice, and I'm slowing this chapter down a little bit. Okay, and F, oh my gosh, this should be like a little T-ball for you, right? Nah? You guys ever like play baseball or softball and you're hitting off a tee? Should be a nice home run, no? Okay, no more sport references. So, how do I find the domain? Yes. Solve for x.
Yeah, and then it's negative 1.
Beautiful. Yep. Wonderful. Lots of examples for you to look at, to go over on homework. So, next, we shall talk about piecewise functions. Do you remember piecewise functions from last year?
No.
If you took Algebra 2 last year with Ms. Coe and Ms. Malikian, they 100% covered it because I went to them and I was ranting about how they were not taught in Algebra 2 2 years ago.
Oh, I do.
So you are the one. Yes.
Oh, those things.
I barely remember this.
Yes. A function that is defined using 2 or more equations for different intervals of the domain is called a piecewise. Literally,
Oh wait,
it's a puzzle.
I've seen this.
You saw it last year.
I did?
Yeah. Trigonometric algebra, they do chapter 1. I thought so. I don't know, whatever. Okay. A function that is defined using 2 or more equations for different intervals of the domain. Literally, it's like a puzzle. You have 2 different puzzle pieces together. It's kind of like if it's like an art project, okay? I give you a bunch of different graphs and you like cut it up and you like paste them together. That's more or less what a piecewise is.
It's like so annoying. Why do we need that?
This is the most important thing that I teach you all year for calculus. Yep. Like, I'm not even joking. If you go to the kids who I have in calc right now, we use piecewise pretty much exclusively because the world is not this nice continuous function. Things change and it's jaggedy. Huh? That was Steve. Hey. It's like, do you guys take physics? Do you know Newton's third law? For every action, there's an equal and opposite reaction. So the powerful thing is in space, in order to get somewhere, you have to leave something behind. That was the first time. Yeah. Newton's third law. Because you can't like have fire in space. There's no air, so you can't oxidize.
What? I'm not in physics, so.
It's fine. And I have 2 puzzle pieces, right? I think this is what a puzzle piece looks like. There's one puzzle piece. And here's my other puzzle piece. Nicely fits in with the other one. That's a nice puzzle piece. Look at those 2 puzzle pieces. How wonderful. All right. So the left one, guess what? If x is less than 0, so this is where x equals 0. If x is less than 0, literally the graph's going to be negative x plus 2. So it'll look something like this. And on the right, my graph is going to be x squared plus 2. So it'll look something like this. So you're literally putting 2 different graphs together. So the first one, you only will have the graph negative x plus 2 if x is less than 0. So how do you actually do this? Step 1, find the values at the jump point. What do I mean when I say jump point?
The starting point.
The place where I'm switching from one function to another, right? So I'm going to, okay. Find values. This is bad. I can't read my own handwriting. Find the values at jump point. So the place where I'm switching is at x equals 0. That's my boundary. That's where I'm switching from one function to the other. So at, let's see, negative x plus 2, that would just be negative 0 plus 2, so that's equal to 2. Let's see, x squared plus 2. Oh my gosh, x squared plus 2, plug it in. I have 0 plus 2, so that's just equal to 2. Check. I found the values at the jump point. Then find one more value on the line. I am using air quotations for line. 2. Second step. Find one more value on the line. Okay, so what I mean by that, let's take this first one. So I circled it in purple. So I see y will equal 2 when x equals 0, right? This first value I plugged in, I found 2. But the issue is it's less than 0, not equal to. So I don't draw a filled in circle, I draw a open circle. Where? At 0, 2. Do we know how to draw this line, negative x plus 2? What is negative x plus 2, right? The intercept is 2. What's the slope? Negative 1. So normally it would go down 1 over 1, down 1 over 1, down 1 over 1. But this is the function only left of x equals 0. So wait, if I want a slope of negative 1, I go over 1 up 1. That way it's going down. Or, as the directions say, if you forget how to draw lines, you just have to pick one more point. So I'll pick negative 1. So 1 plus 2 is 3. So negative 1, 3. And if I connect them, you see, as I go left to right, my slope is negative 1. Notice this graph doesn't go the whole way across, because it's only if x is less than 0. Now this other graph, x squared plus 2, is our value if x is greater than 0. So let me find one more point. How about I plug in 1? So 1 squared plus 2 is going to be 3. But this is a parabola, so I know it's got to be curvy. Right, it's got to have a little curvy curve. Are you guys ready for the calculator portion where I show you how to plot this on your calculator so it shows you what the piecewise will be? Yeah! Okay. So, open up ye old calculator. Go to graph. Okay, so the issue is if you put both of these functions in as like different functions, it's going to draw for the whole graph. I only want it to graph negative x plus 2 if x is less than 0. So I have to go to the template button, which is to the right of the 9 key. Do you see the template button? It is highlighted in red on the screen. You click on it, and then you scroll over to this one right here.
What if there's something already on the graph?
Then you push delete and you clear it. Who's asking me this question? What?
I know.
Yeah.
Did you ask me a question? No. Well, I just cleared it.
So tab, and then you have to click this button and go over to. Guess what I'm gonna put in this box right here? Negative x plus 2. Thank you. Wonderful. Way to fill in the blank. Okay, and this is only if x is less than 0. Wait, how do I get the less than symbol? Control equal. And then it will let me put in an inequality.
Wait, where's equal?
Control, the equals right under the control.
Oh.
And this is x squared plus 2. Oh my gosh, it just plots my, oh my gosh, this is amazing. It just plots my piecewise for me.
I did know.
Wait, so you put the function here, x less than 0. Wait, how do I get the less than? Control equal, and then it pops up the inequalities.
Wait, but do you draw the line
Wait,
on the...
what did I do? What are you doing?
What did I do?
I don't know what I did.
What are you doing? Okay, ready? X, control equal. Not enter, equal. The equal button.
I don't know what I did.
Let me look. What are you doing here? Oh God! What? Oh.
I didn't. It just entered.
Oh, because you forgot to put the second part. Okay.
No, but it's x squared plus 2.
Do I on the y-axis?
It only let
X
me
squared
put
plus
x
2.
squared.
They put the plus 2.
On the y-axis when I'm filling it in, do I put a solid dot or
Ah,
an open dot?
Yes, good question. So, here, it's when x is greater than or equal to, so I have to put a filled circle and match it. So notice, this graph is continuous. There's no holes. The domain for this would be all real numbers, because every x has a y value. Oh, Lord, I thought we would finish. Well, it's 3:15. We went over how to put this on our calculator. We will end here.